Space safety. What is space safety? Okay, so SJC has a Space Safety and Sustainability Project Group. This is not going to be a recruitment talk. It's more the outcome of the projects a little bit, just to give you a little bit of thoughts on some of the ideas that came up out of our discussions. But first, one of the main focuses of the project group has been on space debris, so I thought I could share some numbers. So space debris, you should know that there are dead satellites, waste, spent rocket bodies, tools. There's also a toothbrush. Don't ask me why. It's there. So if you look from the outside at the Earth, you see some image like this. And this is kind of a breakdown. It's old, but still applies, of the different objects that you have there. So the red part says 57% of the objects are actually pieces that have broken off of other satellites or objects. Now there's a rule right now in effect, which is called the 25-year rule, which means anything you send up should come down in 25 years. Doesn't necessarily happen, and some of our results later showed that it's not a good idea. It should be less. This doesn't work. Okay, forget about it. I can talk about it. Not sure. Okay, so some of you might know about the Kessler syndrome, but basically the Kessler syndrome is the idea of objects hitting each other and creating more debris objects that then hit each other and create more debris objects that then hit each other. You get the idea. So I put this video here, which doesn't play, but you can see it online later. It shows the Iridium Cosmos basically collision. That's one of the main cases of collision that has contributed a lot, as I'll show later, to the debris population. And this is what space debris can do to you if you're in space. So you see all of these small holes. I didn't put, there's also images of the solar panels on the space station being hit, for example. This is what we do right now, we shield them. Doesn't necessarily work if you're a solar panel. And the other problem is they can come down. So I'm Canadian. We were affected directly by this because in 1978 there was a Cosmos 954 satellite, which actually included a nuclear power source, and it re-entered, and then it affected parts of northern Canada. There are legal issues here that should take place. They didn't. Actually, Russia just paid off and said it wasn't our fault because it was a dead satellite. So some of the projects that we worked on later are related to nuclear power sources. But you see things can come down, and you wouldn't want to be the person who's standing there when that happens. So especially with the tanks, because of their shape, they usually don't burn in the atmosphere necessarily. So you need to find safer ways if you want to bring them down on Earth. There are legal issues, obviously. Any lawyers here? The lawyers left. Good, so I can talk. There's the treaty on the peaceful use of outer space, obviously. I'm not going to go into that, but there are some UN space debris mitigation guidelines and some national guidelines on the 25-year rule that I said is part of the UN mitigation guidelines. And these are guidelines. They're not law. It means that people don't need to follow it. But the idea is by putting these guidelines in place, in the long run, they become the convention, and then you have conventional law. There's the liability convention, which says if your object hits someone, basically it's your fault. The only problem with it is you cannot properly define who you as basically the liable person is, because it depends on the launch state and there are different definitions. Ask the lawyers. And there are also national regulations that countries have now about space debris. A little bit of ideas. These are old numbers, but still they apply. 999 operating satellites. Objects that we can track are usually 10 centimeters or more. So we can track these guys. These guys can hit, and we can track them. This is the more or less contributions from different countries, and that's one of the problems. So if you calculate things by mass, you can say it's someone else's problem. If you calculate by number, it becomes someone else's problem. So how do you make sure that people understand that it's a global problem and everybody should work on it, as opposed to blaming each other? This is the numbers of the growth, basically the evolution. You see these jumps? Anybody can guess why those jumps happen?
2007.
One is 2007. What happened in 2007?
The Chinese, of course, the Chinese happened.
And the other one is in 2000.
Aureliano?
Okay. So there's a Chinese anti-satellite test in 2007-ish. And then in 2009 there was the Cosmos. And you see these jumps? It's basically a 15% increase in the number of space debris. And then naturally it's growing as well. If you look at the trend line, it was growing before. It's just these contribute a lot. And nowadays people are thinking more about it. This is just showing basically projections of how it would go in different areas, different Earth orbits. And then even if you act, so let's say you have post-mission disposal of the objects that you are launching right now, you still wouldn't, you need a lot of activity and active debris removal according to some studies in order to stabilize the situation. Yeah.
It seems to be some period in that. Why?
That's a good question. I don't know. Because these are not my results. These are results from NASA. I would expect because there are launches and there are objects going down. So I think because these are simulations, probably they had some parameter in the simulation that takes that into account. But yeah, so basically what this shows is to stabilize, you need removal, you need post-mission disposal, which is not what happened now. So I'm going to talk about this because this was how I got involved with SGAC. We did a project on active debris removal, just trying to understand how it works. This is kind of not that new. It's from 3 years ago, 2 years ago maybe. So we did an analysis on the different types of space debris that are out there. If you do that, and this is still valid, you can identify that the main altitude you need to focus on is here, polar, and it's a polar orbits. And there you'll find that most of the objects that are there are actually big rocket bugs. I showed you tanks coming down. These are those tanks. This is an example. So if you look here, the main object is Cosmos. This is a Cosmos. How many of them? 157. And they will come down one day. So then, after we identified this, we said, okay, let's try to come up with an idea of bringing it down. There are different ideas. This is not necessarily the best idea. We came up with this idea of what could happen if we could kind of use an upper stage of a launch vehicle to go and grab this object. The upper stage is supposed to come down anyway, so it brings the objects down, and slowly it can bring things down. So you see it's a phase, it's a 5-phase process. And then we studied it a little bit. We assumed it's the Soyuz, but we did it with a couple of different upper stages. We tried to find out how much fuel, basically how much loss in payload basically you might have, because you need to use some of the fuel of the upper stage to go grab the object, bring it down. We looked at how to connect with it. Different launch sites affected. So Soyuz from Cassettes is different from Soyuz from Kourou. It's different from Proton. Actually, we found that, I think, from my if I remember correctly, Soyuz and Proton were good for this. And then we looked at the safety. So there are tools. I forgot Drama. Yeah, I was looking for that. So Drama is one of the tools that ESA has for assessing the reentry safety risks. We applied it, and we found that even if you do this, it's not safe to come down. Because it's like the upper stage and the other object is too big, so there's a risk that they wouldn't burn completely in reentry. So you need a controlled reentry as well. Looking at controlled deorbits, we found out that it is possible. It's a little bit hard, but with not with Soyuz or Proton, but with American launchers, you could actually do a controlled reentry, which would be safe, and this concept would work. This is another project we did, we were looking at more the policy side of things, to creating a tool for the policymakers to decide if these concepts, like the one I just presented, are viable or not from a policy perspective. So when you think policy, there's a policy and legal framework you should look at. So which nation is involved, what are the legal frameworks of that country. But there are technical things like what I just presented. You have to look at that as well. And then there's the economic side of things. Even if technically it's feasible, economically is it feasible or not? So through that, we developed a kind of scorecard method. We published it in Acta Astronautica, I think. And basically, we assessed Clean Space One, for example, as an example with it, to kind of provide a tool which creates beneficial information for policymakers to make decisions on the different concepts of it. And then now it is Aureliano's turn to talk about a recent project.
Thanks, Eric. Well, I briefly presented it before, but I will talk to you about it here again. So, on-orbit servicing. As we said before, space debris are a big issue, and when we talk about on-orbit servicing, we can also include part of solving the debris problem inside from the safety sustainability point of view. In the sense that in the on-orbit servicing framework, you can include active debris removal and other operations that decrease the possibilities of having debris. For example, where is that? For example, we can think of a satellite that has failed insertion in orbit. It happens. It will happen in the future. Yeah, exactly. 2 years ago. Yeah, don't bring that up. You remember that. Anyway, so it may happen. And if a satellite is put in the wrong orbit, then it's unlikely that it will be able to go in the right orbit. So it will stay there. It will not be able to perform its mission tasks. So it will be dead anyway, or even dead because it has not been designed for that orbit. It might happen too. So what we can do? We could have a satellite that is able to catch it and put in the good orbit. Maybe. Because these are possibilities around the orbit servicing scenarios. So let's see. What we can think of a satellite that is able to do that is also able to perform ordinary tasks. So if it can take and bring a satellite that is put in the wrong orbit in the right orbit, it can also, of course, put a satellite from a low orbit to a higher orbit. It might happen, maybe. The same satellite can do the same, possibly. But there are, of course, pros and cons in this kind of concept. So it can reduce the launch mass of a satellite. Think of going to the geostationary orbit. You will need a big satellite, you need a big launcher, a lot of money. But for example, if you switch from, let's say, an Ariane 5 launch, half of an Ariane 5 launch, with a Vega launch at 300 kilometers altitude, it's 1/10 of the price. So then you will also need to account for the price of the service that brings your satellite from low Earth orbit to geo orbit. But in the meantime, you have reduced quite a lot the expenses. So there is, of course, a drawback. You insert risks in your operations because you insert the docking and undocking of the servicing satellite of the type and of the customer in this sense. So it's risky, and in order to have a sustainable, from the economical point of view, operations, you do need to have precise docking interfaces. You cannot redesign the same vehicle over and over again if your customer changes. So these are some issues that need to be tackled, and also others, of course. So guys I'm working with, they come up with this kind of investigation, thinking about going from LEO to GEO using electrical propulsion. So it takes more time, and of course you need to take into account also another issue in this case. You bring a small satellite from LEO to GEO in 6 months time, for example, but the 6 months time the customer satellite is not working, of course, and you still need to pay the people that are actually maneuvering your satellite for the work part. So there are other costs that one might not think of in the beginning, but they are still there. So this is just a table of recap. Actually, these kind of studies have been done before by NASA, however, focusing on chemical propulsion. So a shorter trip and higher masses involved. So if we think of low thrust orbits and so low thrust propulsion, you can see the difference in mass of what you bring in space. So it might be feasible, and considering that the trend in geosatellite is to go to full electric, so full low thrust also for altitude and just placing, it might be a scenario coupled with the times that are evolving right now in the industry. So this complex graph will wrap up into simply saying that you do need to have maybe a depot in order to your type to go to GEO, then come back without being too massive, otherwise it will be too much costly and the business will not even start. So it might be good, it might be even better than simply a single launch from the perspective of a servicing company if it's able to go back and forth and refuel several times. So you can, let's say, reduces the losses, the costs, and having more reliabilities. This is the same strategy can be applied also for refueling. If you try to refuel just one satellite in GEO, it's not going to work. So you need to plan the activities.
Anybody pay attention to the date on the slide? It wasn't done in 1980. Continue.
Then there are, of course, other issues that maybe engineers, especially engineers, don't think of, that are legal aspects. For example, liabilities. Because you have two satellites that are connecting together, and in an international environment like we are in space, they are probably from different countries, and then international regulation applies for what that is possible. So if there is a failure, that may be, and one has to take that into account, then who's going to pay for that? The launching state, the state of the servicer, or of the customer that is requesting the service? It's an open question still. There are, of course, other issues like standardization norms, technology and knowledge transfer. So there are a lot of issues also from the legal perspective, because something like that has never been done before. For example, all the docking that have happened before, they have a different kind of perspective. There is no client and customer. There are usually agencies, for example. So it's a different perspective, totally from the legal point of view. And since this time contracts are involved, you need to take care of this before. So that brings us to two things. One is we do need to tackle the problem before it gets a problem. When I say problem, I mean issues. So there may be on-orbit servicing, yes, there are still companies that are providing the service. They are claiming to provide the service. There are contracts that have been already signed, companies that have already been dead and not going back, contracts that will be rescinded. So the situation is growing and going and changing fast. There is interest, a lot of companies and spin-off of bigger companies also. But the point is, the issue has not been taken care of and spoken out of from, for example, in the UN caucus. It's not still in the agenda. So what agency is doing this kind of framework is providing the views of the young generation to the, let's say, top brass, let's say. So in the end, that's what we are doing since the last 2 years, trying to tackle the problem, see that it may be good for everybody, but it requires us more study and cooperation and understanding.
Now to wrap it up, there are other topics as well. I mean, you can think of small sats. Yesterday, someone talked about CubeSats. 2 minutes. So small sats has space debris. What's the issue? What can you do? You can think of human Mars missions. We did one on one-way human missions. We did another one on spacesuit safety, just the issues that go into that themselves. Nuclear-powered spacecraft, I just talked to you at the start about it, them coming down, so what are the rules with that? We actually have done 2 reports for the UN COPUS from our side on our views on the nuclear-powered spacecraft. Now, what can you do if you want to be involved, or if you have an idea about these topics, talk to him. Or check out